Okay, I think we'll make a start, and then people may well join as and when they can. I know it's always difficult on a Thursday for people to join us. So, thank you very much, everybody, for joining us this evening, this early afternoon, to the Special Interest Group Wales webinar. And we're very happy to have Ellie with us from the Royal Meteorological Society. One of the things that the special interest group in Wales do is to sort of answer queries and questions that teachers may have to support good geography in Wales. And one of the things that in discussions within our group, we thought that there's really is a lot of misconception out there that we have to counter in the classroom in terms of weather and climate. And so you're kind of battling sort of various interests outside when you're trying to deliver this to your geographers. So I'm going to pass over to Ellie now. If you do have any questions, you want to put something in the chat, please do so as and when it occurs to you, and we'll try and deal with those at the end of the presentation. Okay, so over to you, Ellie.
Brilliant. Thank you very much for having me. And yeah, I will get started with misconceptions and some maybe less known facts amongst students that we've picked up on. Before I get started, I'll just do the quick introduction of the Royal Meteorological Society. So I'm the Education Officer here and I work alongside the Head of Education, who is Professor Sylvia Knight, who some of you may have heard of before or worked with before. Oh, my slides aren't going forward. There we go. So if you haven't heard of the Royal Meteorological Society before, essentially we're the body for meteorologists and climate scientists, and we now have quite a global reach as well, so not just based in the UK. Our headquarters is in Reading, in England, and essentially education is part of our charitable work. The money that we get from our publications and our members is spent on our education work. And we have three sort of strands to our education work. We do teaching resources, which can be found on METLink. If you haven't already looked on there, there's quite a lot of information on there. We have a teacher's guide on there for climate and weather as well, with 20 different chapters, which you might want to go have a look at. But we also do CPD training, and that includes people who are training to become teachers, and we work in policy and curriculum. So there are three main branches. So where did we get these misconceptions from? So we've picked up quite a lot of these, or most of the ones I'm going to present today, from our annual climate literacy survey. So we've just released our survey results for 2025. I'm working on getting out for 2026, and we've had previous years of this as well, and we're just picking up trends from them. This year was the first year where we had opened all the questions to all 4 nations in the UK, and so we've been able to start picking out some national differences. Other misconceptions have been picked up from teaching resources, some well-known ones where we see errors being propagated through different years. And we've also picked some up in a recent assessment material audit that we did. So a number of different sources that we're seeing these pop up in. So to get started, I thought maybe a quick quiz would be a good thing to do to get heads thinking in the weather and climate sphere. So some of these questions are taken from our climate literacy survey or adapted from our climate literacy survey, so they're not exactly the same. Others are just asked because I will go through them in the talk. So I'm going to give you a minute or so to take a look at these 5 questions. And if you've got a piece of paper or a post-it note, to jot down what you think your students would write as the answer to these questions. And then through the talk, we'll go through some of them and maybe you can see which are the correct answers if you are unsure of them on your own. So I'll give you a minute to go through them.
I think you'll have to move your screen up a little bit, Ellie, so we can see the options for question 5.
Question 5 options are exactly the same as question 4, so one of those countries. Well, I will move on. So yeah, keep those in your head and see if you can pick out the correct answers, or maybe where you've tripped up or your students would have tripped up with those. So the first thing I'm going to go through is global warming. How much has the globe warmed? So at the start of 2025, there was a huge media coverage of the state of the climate that was found to have we had in 2024. And the 2024 was said to be the first year to exceed 1.5 degrees Celsius above pre-industrial levels. But what does this mean? What is this value in comparison to the targets that were set in the Paris Agreement? So 2025 was the first year to see global mean temperatures surpass 1.5 degrees above the 1850 temperatures, but that was over a year, so it was only calculated on a 1-year basis. The targets that were agreed in the Paris Agreement, the 1.5 degree target and the 2 degree targets, were not quite the same. They are an average. So the average year, the number of years hasn't exactly been set, but it's somewhere between 10 and 30 years. So to surpass the 1.5 degree target and the 2 degree target, those values have to be met over that 10 or 20 or 30 year period. In the case of 2024, this was only met for 1 year, so we haven't quite surpassed the 1.5 degree target yet. In fact, the state of the climate for 2024, the WMO, so the World Meteorological Organization, actually calculated that so far, over those longer averaging periods, we've surpassed 1.3 degrees, not quite the 1.5. If we look at how our students answered this, or the participants answered this in 2025, we can see some improvements from 2024. However, it's not a great picture overall. So on the left-hand side is the graph comparing the 2024 answers in pink to the 2025 answers in purple. So the biggest difference you can see, there was a huge decrease in the students who said that they didn't know how much the Earth had warmed since 1850. And you can actually see that there is an increase in those selecting the answers around the correct area. So the modal answer, the one that was most chosen, was 1.5 to 1.6 degrees, which is closer to the true value. However, might highlight that some people have been captured by those headlines of 1.5 degrees and therefore equated them to those longer term averages. We can also see an increase in a number of people who are selecting 1.1 to 1.2 degrees warming, which again is around the correct area. However, if we look at the overall number of people that have overestimated the warming, so who have said sort of 1.5 degrees and above, there is a huge majority of people who overestimate how much the globe has warmed. So this is sort of the negative side of it. Some people are getting the answer more correct. However, there is still a huge majority of people overestimating the warming and therefore overestimating or thinking that we've surpassed those 2 degree targets and 1.5 degree target. With the decreasing number of people who have said, I don't know, we have also seen an increase in 2025 of those people underestimating, which is also not a great sign, may relate to people thinking that less action is needed. If we look at it nationally, we can start to look at some national differences. So Wales was actually the country that was most likely to underestimate the warming, with Scotland being the most likely to overestimate the warming. So an unclear picture on just how much students understand global warming. So yeah, so key takeaways of this is that these answers, these responses show that the students aren't aware of the definition of the targets. We have only warmed 1.3 degrees since pre-industrial times. However, the fact that we haven't surpassed the 1.5 degrees target isn't a good thing. It just means that we need to take more action in order to stop ourselves getting to 1.5. If we continue on the way we are now with current emissions, we are on track to surpassing that 1.5 degree target, so more action is needed. Relating to this, let's have a look at the anthropogenic emissions of CO2. So anthropogenic emissions of CO2 are what is causing the current climate change. It's unequivocal that human activities are causing it, and that's what the IPCC, or the word the IPCC used. And we're going to look at sort of blame or who is contributing most to these emissions. So China is often blamed for the large CO2 it contributes to the atmosphere, but is this fair? So let's look at this from current situation. What is happening? What countries are emitting at the moment per year the most? And we're going to look at statistics taken from the Global Carbon Atlas, which are updated up to 2023. So in this image, we can see, or in this graph, we can see that China at the moment is currently emitting the most CO2 into the atmosphere. So at present, it can be said it's contributing the most. And our school leavers have a good understanding of this. When asked to say which is the biggest contributor to greenhouse gas emissions at the moment due to fossil fuel combustion, they are correct. The majority of them correctly select China. And you can see actually that the second most common answer is the USA, which is in fact, as we've seen in this graph, it is the second largest contributor to greenhouse gases. It's interesting to see the difference between 2024 and 2025. So in 2024, more people chose China and less people chose US. And this might indicate people, or our young people, are starting to pick up on political stances. So in 2024, we saw the election of the US president, who used the slogan of drill, baby, drill, and it is associated with some backward steps from renewables and increasing the use of fossil fuels. However, saying that China is emitting the most now, is that fair to make them to blame them overall, looking at the historical emissions as well? And this video from Carbon Brief is a really good visual to show historic emissions of carbon dioxide. So it starts in 1850, which is what we classify as our pre-industrial period. And you can see that the US starts out as the biggest emitter. And I'm just going to let this run through, and you can see how different countries jump up, we go down, and you can see China's growth. So we can see that China's quickly jumping up the rankings at this point. So if we look at historic emissions overall, actually the US stands out over China. So when we asked students to rank the countries in terms of overall emissions, so that includes historic emissions, you can see here that the majority of them put China as the largest emitter overall, and USA second. These two, in fact, are switched. You can see the correct answers, the correct placements of each country in the green. So school leavers are understanding the total emissions, sorry, the emissions currently, but there's less understanding of that historically. We can also look at the, this question showed some misunderstandings of or a misplacement of emphasis on fossil fuels over deforestation. So you can see in Brazil, the majority of students underestimated its overall contributions to CO2 into the atmosphere. And this may be because students are putting more emphasis on the burning and combustion of fossil fuels over the impact that deforestation has. In Brazil, there's a huge amount of deforestation, which bumps it up the list a little bit. So there seems to be a bit of an overemphasis on fossil fuels in this case. If we then have a look at emissions per capita, we can see that this question was really poorly answered by school leavers. Less than, or 5% of school leavers got this correct, identifying Saudi Arabia as the biggest emitter per capita, and they put more emphasis on the US and China. This may be because because students are more aware of areas that they study in geography and case studies or other subjects and case studies, and therefore are less aware of those sort of oil states. If we then look at the rankings, the real rankings of emissions per capita, we can see that Saudi Arabia sits 7th, we can see the USA sits at 12th, and actually the UK, if we're looking for us, doesn't sit in the top 23. So is it fair to point a finger at China? as we look at those results, China would have, or was top two, both in people's understandings of current emissions, emissions per capita, but also historical and total emissions. And this introduces the element of climate justice. So climate justice has emerged from the idea that historical responsibility really lies with wealthy and powerful people, and disproportionately impacts the poorest and the most vulnerable. So if we're pointing fingers at who needs to give most in terms of adaptation and mitigation and financially supporting others, we need to make sure we're pointing to the right people, and therefore our students need an awareness of the big picture of emissions, historic, present and per capita. We understand it can be very hard to provide a fair and balanced picture, especially when specifications are looking at case studies such as China or India. But do use some of those links. Carbon Brief is a great source to look at things at a broader picture, and that use of carbon, the Global Carbon Atlas is a really interesting one to be able to visualize different emissions and the different ways of looking at it per capita, but also as a country as a whole. The next subject I'd like to come onto is climate change in the UK. This year's climate literacy survey showed there was very limited knowledge around climate change in the UK. And that's climate change in terms of the science behind it, but also the impacts it's having and our adaptation and mitigation strategies going forward to take action. So some of the bigger results were that 7 in 10 participants knew that summers are getting hotter and drier. However, only 4 in 10 participants knew winters are getting warmer and wetter. There was quite a lot of people saying that they were getting colder. More than a third of the participants that took part thought that electricity was generated by nuclear fusion in the UK, and 4 in 10 thought electricity was generated by geothermal sources, neither of which strategies are currently used. So there is a lack of knowledge around sort of the different forms of electricity generation. A large majority of participants overestimated how much electricity was generated by fossil fuels last year, with the most popular answer being that 60% of electricity was generated in this way. And unsurprisingly, that's meant that there was an underestimation of the amount of electricity generated by renewable means. I think this highlights that there is a missing of talking about climate change and the work the UK has done in a positive way. We would like climate change to be taught in a way that makes students concerned, but hopeful. And I think in terms of keeping it hopeful, those positive stories need to be told. So even just looking at the Climate Change Committee report from 2025, there are some headlines that we can take and embed into education to have that hopeful aspect to education. So some of the headlines here were that the UK greenhouse gas emissions have more than halved since 1990. So the UK as a whole have put a lot of effort into greening our energy systems. And as a result, we have managed to halve our greenhouse gas emissions. As of October 2024, we no longer have any coal power stations left. Currently, electronic vehicles make up 19.6% of the market share. There was an increase of 59% in the new trees grown in 2023 to 2024 from the previous year. And this is the highest planting rate in 2 decades. Peatland restoration rates have increased by 47% in 2023 and 2024 compared to the previous year. And I think these last two are really important because another thing that we saw in our climate literacy survey was nature-based solutions always seem to come bottom of list. The awareness of them is a lot less over some of the other strategies that we're using. And then finally at the bottom, there was an increase in the use of sustainable aviation fuel as a proportion of all jet fuel used in the UK aviation. It was a small increase, but nevertheless, it was an increase and something that students are less aware of. So to address some of the poorly answered questions from the climate literacy survey, I'll give you some of the correct values. So the National Energy System Operator gives statistics for 2024, and it shows that of the electricity that was used last year in the UK, 43%, just about 44% was generated by renewable energy. And of that was used in the UK last year, around 27% was generated by fossil fuel combustion. So very, very different to what the students had answered. Again, looking at a chart from Carbon Brief, which is a great source, we can see how much the UK's energy has cleaned itself. This is how much how different the emissions have changed. And we're down 2/3 in a decade. So you can see the very end is 2024. You can see that we're on a decreasing trend. So there are positives there. If we look at more worldwide progress, there are positive headlines to be found. So in 2024, 1 in 7 of all new car sales were fully electric. In particular, Norway is a really good story to tell. So in 2024, more EVs on the road. There were more EVs on the road, than petrol diesel cars, and out of 10 sales were electric cars. And this was considered to be a positive tipping point. So a lot of people talk about tipping points in terms of negatives, but there are also positives that we can be teaching when we're talking about tipping points. In 2024, total investment in clean energy technologies and infrastructure was twice that of fossil fuels. In 2024, around March, there was actually a peak in emissions from China, and this is due to their use of renewable energy and their huge investment in that as well. And another one is annual deforestation rates in South America have almost halved compared to the 1990 rates. So there are some positive stories worldwide as well. If you are wanting to look at some of these yourself whilst you're teaching, there are some really good resources for this. So the National Grid shows what's happening live, where energy is being drawn from, whether it be wind, solar, fossil fuels, imports. So it's a really good one to have a look at. The Climate Action Tracker is a bit more of an impact-related thing to look at. It shows how much our actions are actually having impact, rather than just sort of like what action is happening. It shows the actual how well it's doing. As I've been through the climate change report, it's a really good thing to go and take some positive headlines from. Should I Bake is a really fun website that shows you when you should bake, depending on how the electricity in the UK is being generated at that time. And GB Renewables Map is another really good one. It shows where energy is being generated renewably, but it doesn't cover Northern Ireland, but again is a live map and really interesting to look at. The next misunderstanding or misconception that we have picked up from the Climate Literacy Survey is adaptation and mitigation. There is a huge confusion in what they are and the definitions of them. So only 6 in 10 correctly defined adaptation, and less than 45% correctly defined the mitigation, which are very low. This is quite a confusing chart, but it's taken from our Climate Literacy Survey. And it shows you the percentage of respondents that selected each strategy on the left-hand side as adaptation in pink and mitigation in purple. And you can see which one is mitigation and adaptation, depending on what colour they've been shaded on the left-hand side. So I think the first thing to say here is there seems to be more confidence from students, even if misplaced confidence, that in identifying adaptation strategies, almost all of these strategies have been voted more for adaptation than mitigation. Why that is, we don't know, but as you see on the previous slide, there is more people that understand the definition of adaptation. But the second thing we can take from is just the confusion of which strategy sits under which. So if we look at installing solar panels, this is purely a mitigation strategy. It's coloured in blue because it's a mitigation strategy. It doesn't help us respond to impacts of climate change, and therefore isn't an adaptation method. But you can see it's far greater. It's been selected more times as an adaptation strategy than a mitigation strategy, meaning people aren't understanding either what solar panels do, or again, not quite understanding the definitions of them. So there's huge confusion around adaptation and mitigation. We also noticed that there is a lot of misunderstandings around engineered removal of greenhouse gases from the atmosphere. So this is essentially carbon capture and storage. So carbon capture and storage is really poorly understood. Carbon capture and storage is different from a new technology which is called direct carbon capture. So carbon capture and storage from a point source, be it a factory or just a point source. It can be taken out from a chimney or something that's emitting from a direct source. However, direct carbon capture is a new technology in which CO2 is being collected from the atmosphere, not necessarily a single point where it's being emitted, but just taken from the atmosphere anyway. It would seem that a lot of people think that carbon capture is already being used in the UK. And this is increasing from 2024 when just more than 15% thought it was being used. In 2025, we could see just over a quarter of participants thought it was being used. However, it's not actively in use in the UK at present. Instead, when we're talking about carbon capture, we can talk about the pledges that have been made. So as of 2024, £21.7 billion has been put towards carbon capture and storage projects. It is very much part of the UK's net zero transition. And part of that means that they have sponsored or put money into projects that are starting up. So the two key ones that are being looked at the moment are plants in Teesside and Merseyside. And there aren't many places that you can look at of carbon capture storage technologies and places where it's in place. But this Scottish Carbon Capture and Storage website is a really good one. And it shows where certain plans, carbon capture storage plants are in operation, or whether they're in design, or whether they've been cancelled, they've been found not to be good enough, and therefore the locations have been laying dormant. If we look here, this is where we can see the Merseyside and the Teesside plants, which are currently in design, and they're the ones I mentioned previously. So this is quite a good website to have a look at to explore the idea of carbon capture and storage, where it's being used and where it's not. Going back to some of the strategies, the other thing we've picked up on, there's quite a big misunderstanding around the clean air zones in towns and cities. So you can see here that almost 7 in 10 people identified it as an adaptation strategy, and just over 4 in 10 people identified it as a mitigation strategy. However, clean air zones are neither, and they don't necessarily have much to do with climate change as a whole. Instead, they actually focus on reducing particulates in the atmosphere, and therefore help to improve the air quality in urban areas. They essentially reduce the number of cars and producing car emissions in these areas, and therefore reduce the particulates that people breathe in. Car fumes, there seems to be a lot of coverage of this in science in particular, and some of the misconceptions that we're seeing in science are starting to come across to some of the geographical resources that we see. So if we look at the fumes coming out of a car, we've got carbon dioxide, which is a greenhouse gas. We've got sulfur dioxide and nitrogen oxides, which contribute to acid rain. We've got particulate matter, which again can cause respiratory problems, and carbon monoxide that impacts health. And it's nitrous oxide that is a greenhouse gas. And what we're seeing happening is a big a confusion around nitrogen oxides and nitrous oxides. So again, another confusion between what's contributed to climate change and what's contributing to air quality or other environmental impacts. Nitrogen oxides, sorry, I'll go to nitrous oxide first. So nitrous oxide refers to N2O. This is a greenhouse gas, and essentially is produced in combustion engines because it's warm enough there for the nitrogen in the air to react with the oxygen. Whereas nitrogen oxides, which is nitrogen oxide or nitrogen dioxide, aren't a greenhouse gas, and instead they mix with water to produce acidic rain. It turns the rain acidic, and they're associated with smog, which can cause respiratory problems. So there is a difference between these two, and we're seeing an increase in the confusion around them, and this is creeping into educational resources as well. I'm just going to take some water quickly. So they are some of the common climate misconceptions that we're starting to pick up on. But in the next 10-15 minutes, I'm going to go back to some more weather basics. And we're going to look at pressure and high pressure systems. So in a lot of resources, in a lot of exam material as well, we are seeing that pressure is described or explained by the way in which air is moving. High pressure is where air is sinking, and low pressure is where air is rising. So I'm going to present this idea in terms of what happens in a tropical cyclone. So if we look at a typhoon tip is the tropical cyclone that has brought us our lowest surface pressure ever. We got down to a pressure of 870 hectopascals or millibars in the centre of this typhoon. And this is evidencing the fact that tropical cyclones are definitely low pressure systems. However, if we go and think about the way in which we were talking about high pressure being air sinking and low pressure being where air is rising, if we think about the structure of a typhoon or a hurricane or a tropical cyclone, which is the umbrella term for all of them, in the eye, there is sinking air here. And this sinking air is what causes those clear skies. With that thinking, this sinking air in the centre of a tropical cyclone would suggest this typhoon or that the tropical cyclones are high pressure systems. But based off this evidence that they bring us some of our lowest pressures on Earth, we know they are low pressure systems and not high pressure systems. So we need to start thinking or rethinking the way in which we talk about pressure. And actually, the correct way of talking about pressure is the fact that pressure is simply a measure of the weight of the atmosphere pressing down on the Earth's surface as a result of gravity. So the more air above us, the higher the pressure, and the less air above us, the lower the pressure. And when we measure with a barometer, that is what we're measuring. We're measuring the weight of the air rather than the motion of the air up and down. It is correct in that the amount of pressure or the weight of pressure is associated with the rising and falling, but that isn't the reason why pressure is high or low. So let's think about what happens in those tropical cyclones or in cyclones as a whole. So around the eye, around the eye wall, there is lots and lots of rising air. Same as in a depression that we get here in the UK. In the centre of it, there's lots of rising air on both fronts. On the warm front and the cold front, there is rising air. This rising air gets to the tropopause, so that imaginary level that we've drawn between the troposphere and the stratosphere. And the stratosphere is too stable for air to keep going into. So actually at the tropopause, it sort of stops and then diverges. At the top, there is very little friction, and therefore it can diverge quite quickly. Because physics ways to balance everything out, it wants to pull air in at the bottom, at the surface, to replace that that's being lost at the top. But at the surface, we have lots of friction. There's buildings, there's grasses, oceans, there's trees. There is a lot of friction, and this slows down the air that's converging at the surface. So what we have is we have more air being lost at the top than is being brought in at the surface, and therefore the air pressure in the column falls. There is less air in that column, and the weight of it decreases, and that is why we have low pressure in these depressions. If we think about high pressure, it's exactly the same thought. So in a high pressure system, we have sinking air, but that isn't the reason it's a high pressure. You think about how things are converging and diverging. So at the surface, there is convergence. There is air being brought in at the surface. Again, there's very little friction here, so more of it can converge together. At the surface, that air is diverging. Friction slows it down, and therefore the air that's filling in at the top is more than the bottom. More air gathers in that column and therefore causes high pressure because there is more air in it. So when we're talking about air pressure, we need to start thinking about how much air or the weight of air rather than air falling or rising. The other misconception that we see to do with pressure is pressure and air masses. So some people think that when there is an area of high pressure over us, it is determined by a specific air mass. However, this isn't necessarily true. So air masses are large areas of air which have similar temperature and humidity characteristics. And these characteristics are established from the source region and the path taken. So if they're somewhere colder, they're termed polar. Or if they're from somewhere warmer, they're tropical. If they take a path more over ocean, they are maritime air masses. And if they take a path that's more over continent, they're continental. And semi-permanent anticyclones or semi-permanent high pressure areas can be the source regions for these air masses. So the subtropical highs around the globe can be the sources for our air masses, but this doesn't mean that when we have high pressure over us, that it is a certain air mass over us. Instead, when we have a high pressure system over us or an anticyclone over us, it's actually the characteristic of the high pressure that causes the weather that we have, rather than it being a certain air mass. So when we have high pressure over us, the isobars, the pressure gradient is very low, and therefore we get low winds. This means that we have quite settled conditions, which allows the air to warm up. And that warm air can't move away because the winds are so low. The warm air means, or the warming air means that the evaporation increases, and therefore we get clearer skies. This may appear to be tropical continental, so tropical meaning it's warm in its nature, and it's moved over continents, so it hasn't been able to pick up much moisture and therefore is dry. So it might feel like it's a warm, dry air mass, but actually it's the fact that high pressure is sat over us, allowing those conditions to build up, that determines the weather that we have. When we're looking at air masses, we're starting to see really quite confusing pictures being drawn. So normally we have one air mass over the UK at one time. It's very unusual. In fact, we never get 4 different air masses over us at one point. In fact, actually, our most common air mass is polar maritime air mass. Even if we only have one air mass over us at one point, say if we take a polar maritime air mass, it'll be one air mass, but it may cause different weather to happen in different parts of the UK. So when we have our polar maritime air masses, they normally come from a west-southwesterly direction. And actually what they normally do on the west part of the UK, so on the west part of Ireland, but also of mainland UK, this turns out to be cloudy, rainy weather. But actually on the eastern sides of the UK and eastern sides of the Ireland and Scotland and England, we find that actually there's less rain and less cloud. So it's the same air mass, but it's just causing different types of weather in the UK. The only occasion where multiple air masses sit over us is when a front comes through. So a front is simply a boundary between one air mass and another air mass. And this is when we get 2 air masses over us at one point. So these sorts of diagrams can be really confusing, because we're seeing some people pick up and say, well, actually, there are 4 air masses sat over the UK, and that's why they're causing different weather. This is very, very unlikely. Also, be careful when using these charts, because we've seen a couple of resources that have stated that perhaps this part of Ireland can only get polar maritime air masses. Sort of the eastern part of the UK are the only place that can get polar continental air masses. This isn't the case. All parts of the UK can get all types of air mass, not just one specific one. Perhaps this image shows or would indicate that Southeast can only get tropical continental air masses, but that's not the case. So I feel like I've just gone a bit of a whistle-stop tour, but to just do a quick summary of the stuff that I have gone over. So global warming and the targets, these are quite misunderstood amongst our school leavers, but the globe has warmed 1.3 degrees, which means we have not yet passed that 1.5 degrees target, but we are on our way. Climate targets, like the climate itself, so the climate is worked out on a 30-year period. That's exactly the same. The targets are done on a much longer time period, so something between 10 and 30 years. And yeah, we've found overall an overestimation of how much we have warmed to date. linked to this, the emissions that are causing this anthropogenic climate change, it's important to look at emissions in a number of different ways, not only just the current emissions, but historic and per capita, to get an understanding of who is to blame, but also, well, not to blame, who's more responsible, and therefore fair ways of approaching adaptation and mitigation, particularly for those who are more vulnerable and less and have contributed to it less. Climate change in the UK. Our climate literacy survey has highlighted there is little awareness of the impact on the UK, but also very little awareness of the advancements that the UK has made. And these advancements or good news stories are ways of keeping the education positive. It's very easy to get in a very negative way of talking about it, and that creates climate anxiety in young people. Yeah, the UK is regularly generating more than 50% of electricity renewably. So the stats that we were using was a look at the overall electricity used in the UK, and therefore it incorporates how much is imported. But if we look at that's generated in the UK, and therefore not including imports, actually of the electricity that's generated in the UK, 50% of that is generated renewably, which is really positive and something else to be included in teaching. I didn't have time to go through this, but personal mitigation contributions are really misunderstood. So there's a lot of overemphasis on sort of plastics, rather than maybe looking at goods and services and organisations. So there's an underestimation of sort of the footprint of agriculture and therefore the food that people eat. So talking about carbon footprints in terms of goods, services and organisations can sometimes be a little bit better than talking about personal carbon footprints. Clean air zones. So there's a misconception that clean air zones are to combat climate change or our emissions towards climate change, but actually they are more focused on air quality and air pollution. The weather summary is pressure is not defined by the direction of air movement. It is instead a measure of the weight of the air above, how much air is above. And you can simply think about that in terms of going up a flight of stairs. If you have the Firefox app, which is a really good phone app, you can download it and it allows your phone to be used as a weather station, and it looks at pressure. And you can see as you walk up a flight of stairs, the pressure decreases. And that's that idea of there's less air above you when you go up a flight of stairs, therefore the weight of it's less and therefore the pressure is less. So do have a look at the Firefox app. And then finally, the weather when a high pressure system sits over the UK is determined by the high pressure rather than it being the specific air mass that's defining the weather during high pressure systems. So if you would like to, I'm going to give you these questions again and see maybe if you had been caught out by a couple of the misconceptions, and see if you've got the correct answer or whether you could improve your answers. I've hopefully gone through all of these in the talk, but yeah, maybe pick up and see if you have missed out on anything, and yeah, what you can then build into your teaching with your students. And I will leave that up. And I will take any questions. Although I should probably go through the correct answers. just to butt in. I will show the correct answers. I'll go through these first. So yeah, the most common type of air mass is the polar maritime air mass. It comes from north of us, and it takes a journey over the Atlantic and therefore picks enough moisture up to become a maritime air mass. Percentage of electricity used in the UK last year that was generated renewably was 44%. I think I put it as 43 point something percent, but I rounded it on this occasion. The confusion between nitrogen oxides and nitrous oxide. It is nitrous oxide that is the greenhouse gas. It's nitrogen oxide that causes acidic rain and has implications in terms of breathing. China is the largest contributor to CO2 emissions currently on an annual basis, but if we look at it per capita, it's Saudi Arabia that is the biggest emission per capita. So yeah, sorry, questions now.
That's really interesting, Eleanor. Thank you so much. That's brilliant. Absolutely brilliant. It's interesting looking at those questions because, China, I mean, it's so full of contradictions, isn't it? I mean, it's probably one of the largest solar power producers. for local use, and it is investing more in getting rid of his. Well, no, hang on. What do I want to say? It's investing more in renewable power than many, but then it's a bigger country, so it's really difficult, isn't it? And
Yeah.
it has lots of really low quality coal rather than the anthracite stuff, which is burning. So it's an interesting one. And then perhaps students would be quite surprised with Saudi Arabia, but very small population. So
Yeah, and I think it's one of those places that's less covered in case studies.
yes,
We're also
yeah,
starting to see in some of the other questions when talking about impacts, people often select sort of warmer countries to be impacted more purely because they're more studied. So hotter, dry, arid regions, perhaps regions that already have other stresses such as economic development, education issues, they're more well known because they're studied more because there's multiple different factors playing in. And some are maybe the richer, cooler countries that don't have as many contributing factors are less well known.
Yeah.
And that's purely because of, we think it might indicate that sort of case study approach introduces pockets of knowledge. Yeah.
That is the perennial question in geography. Do you do a global overview, or do you have one or two case studies which lead to terrible stereotypes?
Yeah.
And I mean, I think in the developing world and wood fuel, wood as a fuel, which is not good news, but actually it's such a small proportion compared with the annual and the global total. Fiona's internet dropped out, but she's back. So I don't know if you want to take over, Fiona. But one more thing I must say. I mean, the one thing I always found really, really hard for students was was understanding why there is high pressure and why there is low pressure. And I remember a textbook about skaters and having arms together going round and round, and then arms out and slowing down the movement of air. I must go back to it in my old age and look it up again. But it's not easy for students to get a grip on that, is it?
Yeah. And I think so that one in particular is so established in teaching material already. It's really hard when people want to pass exams because they know what's in the mark scheme to then say, actually, we'll teach the correct thing rather than necessarily what will get you the marks.
Yeah. And in fact, I mean, it's not technically wrong at a local level. That, as I understand it, it's when you get into the kind of big atmospheric circulation that it becomes particularly problematic.
Yeah, I'd say in terms of the tropical cyclone, it's very problematic in the sense that there is descending air in that. So yeah.
Yeah, sorry, I was so frustrated, Ellie, because I was coming in and out. The internet here is not as stable as I would hope. I found that absolutely fascinating, and I only got 3 out of 5 on the quiz. So it's obviously there are some things there that absolutely need to be done. I'm sure colleagues who are on the call and those who perhaps will watch the video afterwards will really appreciate the list of different resources that you referenced and places to go for correct, reliable information. I think that is really good. I don't know, Jill, if you asked, I know there was one question in the chat about the questions on the survey. I presume it may be something that'd be useful to do as a starter with pupils in their class to see what information is out there and what misconceptions they're coming into the classroom with as well. So I don't know if you can share that. Have I dropped?
That would be good, actually, Eleanor, if you could perhaps send the survey to Fiona and she could circulate it, or would you be prepared as a method?
It's difficult. So our report is out there and accessible, so people can access it. But it's a case of we don't want it too studied because it will affect the results that we have. So if people are wanting to see it, you can go find our report. It's on our website. So if you're interested in it, do go. And I'd say please in the future, if you see, so it will be live again in January. If you'd like to get your students involved to contribute to this, it would be very much appreciated. The more people we can get, the better. We'd like to build the evidence of where climate or why climate change education is needed. And it's particularly important going forward with all the curriculum changes that are going on in all four nations, to be able to show the impact of changes made would be, yeah, it's really handy. So please get involved going forward.
I think a lot of schools didn't do it because they didn't know about it. So if you could send it to us,
Yes, will
and
do.
the GA, then we can get as many schools on it.
And
And it's
it's
not just, sorry,
it's being translated into Welsh this year, so it's
brilliant.
actually
Oh,
translated
fab.
as we
Oh,
speak.
that's
So hopefully
wonderful.
that will open up the accessibility of it as
Yeah.
well.
So what age group are you looking for, Eleanor? Remind me.
School leavers, so in Wales it's year 11s.
Okay,
We
school
go from
leavers. That sounds okay.
January to March. But yeah, we're very much using it to drive some of our, a lot of our work, some of these
Sure.
addressing where the misconceptions are popping up. And also just the lack of knowledge as well, not necessarily just misconceptions, just lack of awareness of stuff.
Yeah, yeah. I was very interested in the fact that you said there was confusion between the terms adaptation and mitigation. Because those words crop up in exam papers, and it's as much a lesson for the question setters
Yeah.
as it is for the teachers and the pupils to know what we're expecting.
I also think it doesn't help when different exam boards, for this level, if we're looking at year 11s, different exam boards define it in slightly different ways. And we've noticed on a couple of occasions, ads, adaptation, or is it? I can't remember which one it is. Mitigation might be termed in terms of adapting our sort of methods of production, or that word is almost used in both definitions,
Right.
which causes some confusion. So yeah, and also just this use of definitions across subjects would be helpful as well, for all subjects to come together and agree on one definition.
Yeah.
That's where some of the confusion will also be coming in.
Remind me, what was your definition of each? Mitigation was?
Mitigation, I don't know if I put it on here actually.
No, I think you talked about it, but we didn't actually get that far. Too many other
So
things.
mitigation is reducing our emissions of
Full stop.
greenhouse gases into the atmosphere, and that's both by, sorry, or decreasing the concentration. So that's either by reducing emissions or actually actively removing it from the atmosphere. So stuff like carbon capture and storage. Whereas adaptation is adapting to the impacts of climate change. So
It's interesting. Yeah,
learning to live in a world in which climate change is happening. So
yeah,
learning to live with the increased flooding or the extreme heat.
yeah. The challenge, I think, is because we use adaptation mitigation in river flooding, in food security, in lots of different contexts, and it would be really helpful if everybody used the same word in the same context.
Yeah.
We wouldn't have a problem. But yeah, well, that's actually quite very helpful. Thank you.
But yeah, all our definitions can also be found on our website. We've got a glossary on there as well.
I think that's probably the starting point for all teachers, making sure we use the right words in the right place, isn't it? Really. Yeah. Excellent. I think, Fiona's disappeared again. I don't know if there's any other questions, but Ellen, that's been really helpful. Thank you ever so much. It's
Okay.
if there are any more, if there are any teachers who are quietly panicking about rising air and falling air and all that kind of stuff, and nitrous oxides and nitrogen oxide and things, I mean, can we funnel particular questions towards you as the education officer?
Yes, education@rmets.org. Please email us. Do go have a look at our teacher's guide as well, because we've got
Thank you.
rather large areas of work, both in terms of lesson plans, PowerPoints for lessons, but also that we've got some CPD pieces on there, both CPD in terms of videos and reading. You can read them as well, and some of them cover pressure, in particular the high pressure ones. So if you want to go recap,
Right.
some of the pictures and diagrams that I used are taken from that teacher's guide, so that will be another good place to go and start.
Brilliant.
Before people run away, can I just plug? We do a instrument loan. So if you would like to get some instruments into your schools to use in terms of teaching weather and climate, they are free to loan. All you have to do is pay for the postage back to us once you've finished using them. So if you'd like to, again, email education@rmets.org and we will get you booked in for borrowing kit.
That is got to be a best Christmas present. Fantastic. However temporary, that's really good. I'd heard of that actually, a few years ago, and then one of these things you kind of forget about it. But that's absolutely brilliant. So thank you very much. So lots of things there. What kit is available? That's amazing. Thank you very much.
I'll just jump in to answer that if that's all right. So in
Yeah,
terms
please
of
do.
kits, we have primary and secondary kits. I'll just use secondary as an example. In there, you get 10 IR thermometers, you get an anemometer, you get 5 USB thermometers. So they can be left out overnight for a couple of days. You then plug them into your laptop and you get a picture of what's happened with temperature. I think that's it. And in the primary one, you get an additional anemometer and you get a rain gauge as well. We have ones for A level, so we give out kestrels, and we don't have as many of them. They're more for single people doing projects, but they can be borrowed and they are just a bit more advanced. They do humidity, temperature, wind, sort of a lot of them all in one piece of kit. And again, they can be you can connect them to your phone and download the data. I think we're pretty much fully booked for spring next year. But if you are ready for the 2026-2027 academic year, which is quite scary to say, we are booking up into them already. So, we're taking bookings for them already. So do get in contact with us and I will get you booked in.
That's fantastic. How long do you loan the stuff out for? I mean,
You get them for a term. So for a term, so we send them out at the start of the term, and as long as you get them back to us before you go on holiday at the end of the term, that's perfect.
Wow, that's very generous. I would have thought, a month would have been, to keep the things circulating. That's wonderful. Ellie, thank you very much indeed. It's been really useful, and I'm going to let you go, but it's been a great addition. Thank you.
Thank you.